Hello, am I audible? Hello. Hello, am I audible? Please respond in the chat box. Okay, fine then. So, in today's class, we will start off with a new topic called as cross drainage walk. Okay. So, what is this cross drainage walk? Drainage walk is nothing but a structure that is constructed whenever there is a crossing between the canal and the natural drain. When I talk a natural drain, mean either a river or a stream. As you can see in this picture, okay, there is a canal here, and this canal have to cross the a natural drain. Yeah? There is a river here and there is a canal, so it has to cross this river. So in order to prevent the mixing of water between the water carrying by the canals and the water carrying by the river, we construct some kind of a structure called as a cross drainage walk. You can see here is written, so irrigation canal, while they carry water from the headwalk to the crop field or wherever is intended to carry. Okay, so sometimes they have to cross the natural drainage such as the stream, the nala, the rivers and all. So to cross this drainage safely, so we have to construct some kind of a structure. So this kind of a structure that are constructed at the meeting point between the natural drainage and the canals are called as the cross drainage walk. Okay, so you see here this is called as a cross drainage walk. So generally these kind of a structure are very costly to construct. So we often try to avoid constructing this kind of a structure because they are very costly in nature. So whenever we design a canal, we try to align the canal in such a way to avoid this kind of a structure. Okay, anyway, so depending upon what is above, whether the river is above or the canal is above, or whether the canal is below or the river is below, depending upon what is the bed level, water level, depending upon the kind of pressure that these structures are subjected, we classify the cross drainage walk into four categories. One category is called as the type 1, whereby the irrigation canal passes over the drainage. That means the canal is on top the drainage, like you see here, right? Here the canal is on top the river. Drainage basically it means the rivers or the stream. So that kind of a structure falls into the category type 1. And here we have, under this type 1, we have aqueduct and siphon aqueduct. There is a type 2 category whereby the drainage passes over the irrigation canal. So in this case, the river or the stream is above the canal. So in this category, we have again structure called as superpassage and siphon superpassage. And sometime when the water carried by the canal and the water carried by the river, they are of the same quality and the quality of the water does not matter so much. In that case, sometimes we allow them to mix together. So in this case, then it falls into the category 3, whereby the drainage and the canal are intersecting each other and they are of the same level. So in type 3, we have the level crossing and the inlet and outlet. So these are the three type of cross drainage walk. The first case, the irrigation canals are on top of the drainage. The second case, the drainage is on top of the irrigation canal. And in the third case, there is an intersection between the drainage and the canal. Okay. So within each type, we have two types. So let us see, okay, how do we select what type of a cross drainage walk to construct? It depends upon the relative bed level. It depends upon the suitable foundation. Okay, we have to see. Uh, so what is the suitable foundation for the river as well as the canal? So this thing we have to see. We have to see about regarding the economy, how much is the cost, how much is the discharge of the drainage, how much is the maximum discharge of the river. All these things we have to see while selecting the type of cross drainage work. So let us see the first type of a cross drainage work, that is called as the type 1, whereby the canal is over the river. Okay, so like I've said, in type 1 there are two types. One is aqueduct and the other one is siphon aqueduct. So let us see first about the aqueduct. So it's written here, the hydraulic structure in which the irrigation canal is over the drainage such as the river and stream is known as aqueduct. In this kind of structure, okay, this kind of structure are constructed when the bed level of the canal is above the highest flood level of the river. If you see here, okay, this is the bed of the river and this is the highest flood level of the river. Okay, that means this is the maximum level of water that is ever being recorded in a river. And then on top of that, we construct a canal which is well above the, whereby the bed of this canal is well above the highest flood level. That means there is a huge gap between the highest flood level of a river and the bed level of the canal. So this kind of a structure is called as aqueduct. Okay, this kind of a structure whereby let me unlock the meeting. Okay, this kind of a structure whereby there is a sufficient gap between the highest flood level of a natural drainage and the bed level of a canal is called as aqueduct. And here the water is flowing under atmospheric pressure. Okay, you have to note down here that the water is flowing here in both the cases, in both the canal uh, as well as the natural drainage. The water is flowing in with under the atmospheric pressure. You see here, okay, here we have the canal on top and the rivers below, and there is a sufficient, this is the highest flood level, and there is sufficient distance between the highest flood level and the bed of the canal. So this kind of a structure is called as aqueduct. So you see here, okay, so maybe the highest flood level of this river is around here. Okay, this is the maybe the full supply level, and then here around is the highest flood level. Okay, highest flood level here. So you see here that the bed of this canal is well above the highest flood level of the river, and this kind of a structure are called as the aqueduct. You see here, the river is below and the canal is on top. And on top of that, we have this kind of a road, inspection road. See here, we have this road, right? You can see here, road on both sides, whereby we can inspect both the river as well as the canal. So this kind of a structure is called as aqueduct. Is it clear to everyone? What is aqueduct? Is it clear or not? Hello? Okay, fine then. Fine then. So next, again, we are still in the type 1. Okay, that means the canal is on top of the river. The second type is called as the siphon aqueducts. Here, the canal is still on top of the river. But what happened? The drainage water cannot pass the canal easily. It is because what happened here? The structure here, the bed level of the canal is below the highest flood level. So if you remember, in case of the aqueduct, the bed level, there is a sufficient gap between the highest flood level of the river and the bed level of the canal. Okay, that is in case of the aqueduct. In case of the siphon aqueduct, the bed level is below the highest flood level. Even though the canal is still on top of the river, but the bed level of the canal here is well below the highest flood level. You see here, okay, so this is the highest flood level of a river and this is the bed level of the canal. So that means the bed level of the canal is below the highest flood level. So that's why this is under pressure. That's why it's called as it is under siphonic action. That's why it is called as siphon aqueduct, because the pressure here is under siphonic action. If you see here, this is a canal. Okay, so if you see, the bed level of the canal is somewhere around here, and this is the river, right? So that means it is well below the highest flood level. That's why it is under pressure, under siphonic pressure, and that's why the name is called a siphon aqueduct. The canal is still on top of the river, but it is the bed level of the canal is well below the highest flood level. So this is the type 1 whereby we have the canal is on top of the river. So let us discuss the type 2 whereby the drainage or the river and streams are on top of the irrigation canal. So here also we have two kind of a structure. The first type is called as the super passage. Okay, so here in case of a super passage, the structure is suitable when the bed level of the drainage is above the full supply level of the canal. See here. Okay, so here the river is on top the canal. So here this is the full supply level of the canal, and there is a sufficient gap between the full supply level and the bed level of the river. So this kind of a structure whereby the river is on top the canal and there is sufficient gap between the full supply level of the canal and the bed level of the river is called as a super passage. You see here, okay, this is a canal here. This is the full supply level of the canal. There is a river coming here and we construct some kind of a structure so that the river will pass on top of the canal. Okay, so the gap between this full supply level of the canal and the river is called as a freeboard. There is sufficient freeboard, okay, between the canal and the river, and this kind of a structure is called a super passage. Then we have, apart from super passage, we have the different type whereby we call it a siphon super passage. Again, in case of a super passage, the river, both the water flows under atmospheric pressure. However, in case of a siphon super passage, the structure, okay, the bed level of the river is below the full supply level of the canal. Okay, the bed level of the drainage of the river is below the full supply of the canal. You see here. So this is the river is on top. Okay, the canal is below. But what happened? The bed level of the river is well below the full supply of the canal. So this kind of a structure, because the bed level is below the full supply, so it's under pressure, it's under the siphonic action. That's why it's called as siphon super passage. Okay. Then apart from this type 1 and type 2, we have the other type of a cross drainage structure called as the type 3, whereby the drainage and the canals are allowed to intersect each other. Okay, read here. Okay, when the bed level of the canal and the streams are approximately the same and the quality of water in the canal as well as in the stream is not much different, in that case we allow it to mix each other, and in this case we construct one kind of a structure called as the level crossing. Okay, so you see here, this is the canal and this is a river. They are mixing to each other. Like here it become more clear. Okay, so here is the river and here is a canal, and here we have some kind of a regulator whereby we control how much amount of water is coming from the canal, and then again here we have some kind of a regulator how much amount of water is allowed to go out. All these are under the same level. Both the canal as well as the river, they are under the same bed level. And then we have a regulator here to allow how much this canal, the water is coming from the canal, should come here and mix with the natural river, and how much water is should be again diverted here in this canal. So this kind of a structure whereby we allow the water that is carrying from the canal to mix with the water that is coming from the natural stream or the river is called as the level crossing. And then we have the last type of the type 3 called as the inlet and outlet structure. Okay, here also what happened you see here, when the irrigation canals meet a small stream or drain at the same level, it's allowed to enter the canal as the inlet. Here you see here, okay? there is a small water coming here, small drain of water is coming here. So here we have an inlet whereby we allow this water to mix with the water in the canal. See, this is a cross section, you see here, the water is coming here and we have some kind of pipe here, okay, pipe structure whereby we control the water, how much water is coming and mix with the canal here. Then at some point, some location, so again we divert this water using an outlet, okay, into a again some small drain. So here all both the uh, uh, inlet, both the canal as well as the natural drainage are of the same level. So this is about the cross drainage walk and the type of the cross drainage walk. So let me again just revise what I have just said. So sometime, okay, it happens that the canals have to cross by the natural drainage, that is the river and the stream. So we, in order to avoid mixing of the water coming from the canal and the stream, we construct some kind of a structure called as a cross drainage structure. So generally when we construct a canal, we try to avoid this kind of a structure because they are very costly in nature. So we try to design a canal in such a way to align it in such a way to avoid some the cross drainage walk. So then I said that there are three types of cross drainage walk. Type 1 whereby the canal is on top of the drainage. In this case, we have the aqueduct and siphon aqueduct. Then we have the type 2 whereby the river is on top the irrigation canal. So here we have the super passage and the siphon super passage. And the type 3 whereby the canals and the drainage are allowed to intersect each other. And here we have the level crossing and the inlet and the outlet. Okay, so in case of a aqueduct, so here the bed level of the canal is well above the highest flood level. You see here, the bed level of the canal is well above the highest flood level. There's a sufficient gap between the bed level of the canal and the highest flood level of the river. That's why both the water are under atmospheric pressure. However, in case of a siphon aqueduct, the, the bed level of the canal is below the highest flood level. Then we talk about the type 2 whereby we talk about the super passage. Here the, the full supply level of the canal is the bed level of the river is well above the full supply of the canal, okay, and in this case both the water is flowing under atmospheric pressure. However, in case of a siphon super passage, the the full supply level, okay, the full supply level, the bed level of the river is below the full supply level. Then we talk about the level crossing. Here you see, so we have a regulator whereby we allow how much water coming from the canals to mix with the natural water, and then we have again a regulator here to allow how much water to come out. So here both the canals and the river are in the same level. Likewise in case of the inlet and outlet. So this is about the cross drainage walk. Any doubt? Is it clear to everyone or not? Is it clear to everyone? Okay. Okay, then again, you please mark your attendance in that Google sheet that I have shared last time. So please mark your attendance, and accordingly I will inlet and outlet. Okay. So here inlet and outlet, what happened here? You see here. Here, let me read. Okay, when the irrigation canals meet a small stream, so there is a small stream, small river, okay, whereby the canals have to meet this small stream or small river. So here what we do, there is some kind of a pipe, okay, we make some kind of a pipe whereby to allow the water that is coming from the small stream or small river to come and mix with the with the canal, okay. Then here we have an inlet whereby we control how much water that is coming from the small stream to mix with the canal. And then at some junction, at some downstream part of the canal, again we have an outlet whereby we allow the water, some part of water again to flow into here again we have some kind of a stream here, small stream, and then we allow the water to again to flow from the small stream using this outlet. So similar to this level crossing only, okay, but here in the inlet and outlet, we have a very small river that is meeting with the canal. So we have here an inlet to control how much amount of this water that is coming from this small stream, how much amount of this water should mix with the canal. And then at some point at the downstream end of the canal, we have an outlet whereby we control how much amount of water should come out from the canal and join this another stream that is present here. So this is about the inlet and outlet. And remember that both the inlet, outlet, and the canals, they are of the same level. As you can see here, they are of the same level. Likewise, here also the same level. That's why we can do this mixing part of the water that is coming from the river as well as the water that is present in the canal. So is it clear, Ivan? Is it clear? Okay. Any more question? If not, then you can leave the class. Okay. Mark your attendance in the Google Sheet. Okay. Thank you.